Hello and welcome to a new video. Today we're gonna see about VSL. I don't know what that noise is, sorry. Okay, so which stands for B Scientific Library. I am working on a big project that searches for better solutions to problems. I guess we can call this an optimization problem, and it just searches by brute force. So I want to see how can I use VSL to accelerate this. So VSL, I think we have let me see, around here probably we have something related to VSL tutorials. No, it's not there. BPM, I guess it is, right? And here we have a packages, and actually VSL is the most downloaded one. Is that correct? Oh yeah, I didn't know that. Okay, it has 257,000 downloads. So if we go to here, it says the B Scientific Library. VSL is a B library to develop artificial intelligence and high-performance scientific computations. Okay. Visit VSL docs to know more about the supported features. Okay, let's do that. It's the same. Oh, it's docs. But I am in VSL docs. Okay, it still says this. Okay. VSL is a scientific library with great variety of different modules. Although most modules offer pure B definitions, VSL also provides modules that wrap known C libraries among other backends that allow high-performance computing as an alternative. This library contains essential functions for linear algebra computations, operations between all combinations of vectors, matrices, eigenvalues, eigenvectors, linear solvers, and the development of numerical methods, numerical quadrature. Optionally, we'll link VSL with existing libraries written in C and Fortran, such as OpenBLAS and LAPACK. These existing libraries have been fundamental for the development of high-performance simulations over many years. We believe that it is possible to rewrite these libraries in native B and at the same time achieve the same speed delivered by them. But at the same time, we want to allow users of a VSL the possibility to choose when to use these libraries as a backend and when not. That is why each module documents the flags that allow this at the time of use. Installation. It is possible to optimize certain modules using different backends. For these, there are some C dependencies that can be installed optionally. If you want to use these C dependencies with other libraries, the easiest way to work with VSL is via Docker. Having Docker and VS Code installed, you can start developing powerful numerical simulations using VSL in a matter of seconds. Furthermore, the best part of it is that it works in Windows, Linux, and macOS out of the box. Well, I use Linux, so that's cool. Quick containerized recommended. Install Docker, clone hello VSL, follow the instructions, done. Install VSL locally. Okay, I'll try to do this locally, right? I recently updated B. You can do that with B app. So just to see. As you can see, it takes longer than it should, but okay. Current version is 0.4.5. Okay, that's the current version of B. Okay, great. Now I will do B install VSL as it says here. I don't know if I have it installed. We will see. Updating. Okay, it's done. Done, installation completed. Test the module, just type the following command, btest dot. I don't know if that's gonna work, because I'm not in the correct directory, right? I don't know, really. Maybe this is a standard thing in B, but it's not working. I think it's not what it's supposed to be doing, because that dot specifies like the current directory, I guess, and it's just treating my whole environment as the current directory, which is not something that I like to do. Right? Okay. So that has to be run from inside some project, I guess. Okay, so now we have a hello BSL thing right here, so I might as well clone this, right? Let me see. Let me see if I can, I mean, ls into something or cd into something. So the other project, I guess it's Vlang cool algorithms. Is this the one? Yes, that's correct. So cd, actually just clone it here. Hello BSL, it's been cloned and it's done. And now if we cd into hello BSL, we would do, probably here we will test the command we used previously. It says test. Okay, be run dot. Is that how we do this? I don't know. Unknown function BSL func new func. Okay, so let me see what's going on here. Follow the instructions in the readme.md file. Okay, I'm not following the instructions in the readme.md file. Oh, this is for the Docker thing. But let's see if I can do it without Docker. Can I? Hello BSL. Oh, maybe this is the one that I should have cloned or not. This is like recursive. Okay. Okay. Well, what if I do something else? Like just b dot. Still, we have some sort of a problem here. It may be that BSL new func. I don't know, but it may be that that this is only for Docker, or maybe it's just outdated compared to the current version of B that I'm using. It very well may be. I don't know if we have more samples here. Let me see. So here in B, we probably have some samples. All right. Examples. Then probably BSL somewhere. BSL. Not appearing anything that I can see. Maybe in these files right here. Apparently no BSL for me. Let's see if we can search for BSL. Where's the search thing? Okay. BSL. I guess this is a separate library, right? I don't know. Let's just search in whole GitHub then. Repos. Let's do language B. I would just say B. And we don't. We only have these two things. And so yes, so we don't have a lot more than this. But here in VSL we have examples. So sorry, here is the place I should go. Oh, okay, so here's what I'm looking for actually. Okay. Okay, so this I think is something interesting for this purpose. Okay, sounds good. Now, maybe I should clone this guy instead. So I will do a cd out, and I will remove the thing that I just cloned because I don't need that, and I will clone the new one. I probably don't need the history, so I would say dep1. I think that's how you do it. Not an expert on Git by any means, but okay. Oh no, it's not examples, just what the hell? What's this? Oh, 3 it says just there. Cloning to VSL. So we're waiting. It's done. Now we can cd into VSL. And here we are. And what's inside bin? Let's see. Test util. So this is the library by itself. So I would like to cd into the examples. Okay. I would like to also go there in my file manager. Where is this? Okay. Examples, where are you? Here. Okay. So there's lots of things right here, and what I would like to do now is I'd like to decide which of this I want to test first. For that, I will probably I would like to see the size of the folder, in kilobytes, to go with the smaller. Is this how would you do this? dfdh? No, that's not how you do this. df dot. Nope. lsla. Oh, but it shows everything the same thing. Okay, let's ask the internet how to show the size of folders from Linux terminal. Let's see. What can we find? DUHS. Is that what I'm looking for? DUHS dot? No. Having a call. Okay, let's continue. So I was trying to find how to do this, but it's a bit hard to do, right? This is the one that I probably need. I don't know. Oh yes, this is the one. So we have some of them that have 8 kilobytes, some of them 24, 12, 16, 56, and all that. Well, I'm happy to say that it's not that big. 8 kilobytes not that much, so I would like that. I would say that's kind of okay. But then we have something that says plot, something that says prime factorization. I like this prime factorization. Probably would try to do that first. Okay, so let's go into prime factorization. Let's open a new terminal here, and I'll do cd prime factorization. Ouch. Oh, my hand just hurt. And here what we'll do is we'll do b dot. Okay, and here we have our prime factorization thing, and if we run this, we will get something. Well, apparently not. Maybe it's running, maybe it's not, but because I don't know the code, I haven't looked into the code yet. So apparently no high CPU usages, so probably it's doing nothing, or probably it's waiting for me to do something. Oh yeah, I guess. Oh. What the hell, did it just crash the system, the program? Well, probably, I don't know. So I guess I have to look into the code of this thing. How do I look into the code of this thing? I can do nano or something, but I probably would prefer to open it in IntelliJ IDEA. And for that, I probably would like to do a copy of all these things. And I would like to copy examples, but I would like to rename this to VSL examples, so that I have the context that these are examples for VSL. And I'll copy and I will paste it just here. Okay, I don't know how big this is. I guess less than a megabyte, right? 1.8 megabyte. Well, that's fine. Okay, so now I can go to IntelliJ. And here in IntelliJ, we can see what we have. VSL examples right here, and then we can go to prime factorization main.b, and here we have the code. Okay, so what's the code doing? Okay, the code is getting an input, and then it factorizes that input. Okay? Okay, so prints the factors of these things. However, I run into a problem because what I did, well, let's run from here. I guess we can do this. Okay, here it's at 32. Oh, I cannot input here. Or can I? Okay, it says array set index out of range. In even this very simple example, we have a bug, so that's not good. But so where it comes from, well, I'm not really sure, but we'll see if we can find it. So I guess we're talking about for f in factors. I guess the problem is inside factorize, right? For n different than 1, n divided by x factors here. SPF for p in sieve, prime sieve. Prime sieve, where is this guy? It's from math. But I don't know when it is this using the VSL thing. Oh, okay, this is from VSL then. Okay. But this prime is from module prime. Okay. For in module, this prime is from VSL. Oh, okay. This is the VSL. Okay. So yes, here we have these VSL things, and have lots of other things like prime and others, because we installed that thing. But now, if we want to find the problem, well, how can we do this? Does this thing here, as you can see, it says by VSL prime sieve. So this apparently has a bug in the library, I guess. We're talking about here probably for int3, right? I don't know. Prime sieve, and then you have what says range, and range is x, and SPF x is n, and then is what I passed it here, and it's being divided. So this thing has a bug, a quite serious bug, but the thing is that we probably can do something about this. Yes, not sure though, because I mean, inside this prime thing, I guess this is doing some, it's using some acceleration, right? Otherwise, what would be the point of it, right? I guess. However, I don't see any acceleration taking place here, because really this prime sieve is being called by this, and this is just at the same time being called by this, and I mean, this is not using any fancy thing. So the fancy things should be inside this one, this prime sieve, I guess. But I don't see it. So, sorry, this is not acceleration. It's like scientific but not accelerated. So probably I should go and see another, thing that has acceleration. OpenCL basic. OpenCL 1x image example. Should I do that? The largest one. Okay. VCL, OpenCL image example. We'll do B dot. Is that correct? And then VCL. And I don't know what it does. But okay, I guess I can just see it in the code. So I create an output directory, reads the file, which is kernel CL, which I think is some sort of pixel manipulation thing. It says invert. Okay. And then it writes the image back. Oh, so the image is the result the same image, right? Well, let's see. So we have it says Julia right here. Have that, and then we can run it again, and the image should change. Is that correct? Well, I don't know really. Did it change? I don't know. But okay, let's continue with code. This is the kernel. So it reads the kernel, which is CL, which I guess is for OpenCL, which is computing library, right? I guess. I don't know. Or computing language, whatever. I don't really know. Then you get the default device. Okay, BCL get default device. Okay. CL device get platforms. Okay, so this I guess could get the GPU device, I guess. Then it loads the kernel. STBI, what's this? I want this to be wrapped. Okay, let's see. Okay, it says STBI is a thin wrapper around STB image, which in turn is a public domain image loader for popular graphic image file formats. So image release device add program invert core lower kernel device kernel invert global end bound. So I think this is capable of using GPU, even if maybe it's not using GPU. So this probably is capable of that. So acceleration, this is acceleration, and it didn't crash, so better. Yeah, but the output directory, what's this? Output. Oh, it's the output. I'm wrong. I'm horribly wrong. So, but, oh, here you have the output. Inverted.png. Okay, I see that. So let's see what can we do here. Idea project. Sometimes I'm be distracted and don't read the code. This is not right. Yeah, this is not. Oh, so here, we can go into VSL examples, image example, and then, but we don't have the output here. Oh yeah, of course we don't, because it's not from, or is it? Oh, isn't VSL examples? Or where is this thing? Wait. Image example, and then we have output. OpenCL image example, and then we have an output. Okay. OpenCL image example, and I don't have an output here. What's going on? Oh, I'm not in the right directory. I'm not in the right directory. I didn't run this. So I will run it now from here. I'm in another directory. Now it's an output. So what is the thing that I was doing wrong? Is this, basically. Because I got confused with this. I think this is an alt clone or something. Or just a clone. So here I should have done cd Vlang cool algorithms, and here cd VSL, and now we are in the right place, which is cd VCL open image example, and now this is the one that's okay. So now in output we have inverted. So this is the inverted one, and this is the original one. Okay, so yeah, it works. It's inverted. So it's doing some sort of acceleration. And this really gives us like something or some toy to play with, right? Because this is an example of proof of concept or whatever it is on how to use the VSL library. So looks good to me. Looks good to me. Basically, looks good to me. Now let's understand the code, right? Okay, so if I want to understand the code, well, I was trying to, but okay, it makes a directory, then reloads the kernel, which is the one that we have here. This is the kernel. I don't know. This is written in OpenCL. Okay. So it's using OpenCL as the API. Something that I would like to know is how large is the result of this thing. So it's not being built. So let's do b dot to build it. And then here we do right-click properties, 2.4 megabytes. That's not that much. It's not that much. So I'm happy with that. Yeah, I guess in theory, a 2.4 megabyte executable that can use accelerations, very, very, very good, I would say. So okay, so it inverts from, this is the inversion code, like 1 minus this thing, and basically that's it. So yes, if the device is CPU, unsafe platform ideas, device type, CL device type CPU, GPU, CPU. So it gets the CPU. Get all devices if you want. Then it prints the devices. Oh, okay. But where is this? What's this thing? It's B OpenCL basic main.b. Okay. I would like to print this. I would like to have this code in my other thing. Okay, so I'll print the devices in this way. And yes, I guess I can just run this. Oh, it detects my NVIDIA card. That's good. It says devices, NVIDIA GeForce GTX 1650 NVIDIA Corporation. Okay. But it says device type CPU and it's printing a GPU. So kind of strange. So probably, what if I say all? Oh, this is not. Oh yeah, this is the one. All. Still just one device. Just the GPU. It's not detecting the CPU. And get default device. What if I do GPU then? A problem apparently. BCL.cl device not found. Well, if I say CPU, it shows the NVIDIA card. If I say GPU, it says nothing. Okay, let's do something here. Let's load this device. Or probably something better. Let's print the device actually. Well, NVIDIA, it says. Lots of things that I don't know about about B, but okay, pretty new to all of this actually. So I guess this is using the GPU. I guess. I guess, but it definitely has some bugs. So, but yes, but still, kind of works, right? Yeah, I would like to know how I was using in my code. I mean, the code that I wrote, benchmarking thing, which was now MS. I don't know if I can include that in here. Oh, this prem thing didn't work well. Okay, let's see. Oh yeah, this is in my main thing. Now MS, can that access? I don't think it can access now MS. That's hard. I'll just copy it from here for now. You know, sometimes you have to be like practical and do whatever it's it's more straightforward to do. Okay, with this I want to how to say it, benchmark the thing. Okay, I would do something like fn, let's say run or whatever, just to put all of this in a single in another function, just for benchmarking purposes, right? I guess. Okay, so I will call run, but I'll do t0. I'll define it as now ms, then run, and then t1, define it as now ms again. And here we'll do oh well, but what about the well, our good old friend well? Okay, well, well, donning t1 minus d0 ms, because this is in ms. So we run this and we have a problem. Why do we have a problem? Error to propagate result call. Run must return a result. Must return a result. What do you mean? Is this what is this thing asking me? Error to propagate the result call. OS read file. What do you mean? Oh, okay. 32. So, this one. Why? I mean, why though? Why? I mean, why so many things to have to do? I mean, what the hell? To propagate a result call, run must return a result. Run CL. Oh yeah, I cannot do that. must return a result. Result? Is that how you return the result? I don't know. I mean, oh. To propagate the result call, run CL must return a result. Or return. I mean, I feel that I don't understand this at all. Okay. What do you mean? I don't know, we'll find an answer. Of course. But why not from the main function? It doesn't. If I run it from the main function, it doesn't require any of this. I don't get that. Really, I don't get that. Because maybe it returns to whatever. Resolved, it says. Result. We have docs here. I mean, nil. Option types are for types which may represent none. Result types may represent an error returned from a function. Option types are declared by prepending to the type. Result types use that. Okay, how to use them. Return error. User. Okay. Okay. A return error. Oh. I guess I know. I now understand this. I guess now I understand this. Kind of odd though, but okay, so how do we do this? Okay, so I guess the way we do this is main.b but what am I doing? Oh, this is not the one. Oh, sorry. I'm wrong. Okay, so here, I guess what I should do is do or, and then return error. And I say return error, right? Right? Right. Okay. Okay, now in 28, it says, oh, make deer. Oh, okay, so sorry. Return error. Right? Right. I guess. Cannot use as type result. I error. Then change it to I error. And do the same for all the cases. And it says, oh, or, sorry. It's a bit tedious to do this, you know? I guess, is this the way to solve it? Is there another way of solving it? Let me know, right? So, I don't know. Really, have to do all of this. And it says missing return at the end of the function. How do I do this? I don't know how to create a new object of this kind. Result okay. Is that? No, I don't think that's. I don't know. Okay. Let's see. The ones I'm more familiar with. I guess I can just do this then. Right? Yes or no? Oh yeah. Okay. What about that? Oh, it worked. That's great. Done in 558 milliseconds. Well, this was a tedious thing to do, and not the most efficient way of learning B or VSL or whatever. But you know, they say learning by doing is okay. So here we go. So it was kind of okay, kind of fine. I still have to keep, exploring more about BSL and B in general. But yeah, it looks fine. Not perfect though, but still lots to explore. Not the final verdict. So thank you for watching. I hope you enjoyed the video, and leave a like, comment, and I see you on the next one.